Hello dear students, I am Chetan Singadia from Dr. Subhash Technical Campus. You are watching the video lecture series for the subject of Database Management System. In this video lecture, we are going to discuss decomposition of relation in DBMS. The decomposition of relation, we can say it is a decomposition technique of a relation, or they may be simply asked about explain the decomposition techniques in DBMS with an example. So let us start with these decomposition techniques in DBMS. So dear students, in this video lecture we will learn what is decomposition, what is the meaning of decomposition, how we can define the decomposition with an example of a relation. There are two types of decomposition, or we can say two techniques of decomposition, or we can say the decomposition of relation can be categorized or the two types, that is lossless decomposition with an example and another one that is lossy decomposition. So we are going to see this both the techniques of decomposition with an example in this video lecture. Now let us understand what is decomposition. The decomposition means when a relation in the relational model is not appropriate normal form, then the decomposition of relation is required. So according to the definition, you would have to understand that why we need a decomposition. Whenever our database is not in appropriate form, or we can say it is not in an appropriate design, so in such case we have to decompose our relation, decompose our table. That is an important thing. That means we have to decomposition of our relation that is required according to the decomposition in DBMS. In database, it breaks the table into multiple tables. So this is the main important part of this decomposition. What is the main aim of this decomposition? While using decomposition, we are going to break our table into multiple tables. If the table has no proper decomposition, then it may lead to problems like loss of information. So while using decomposition, user has to keep in mind that while data loss of the information should not be allowed. That means if a relation has no proper decomposition, that means if you are not providing proper decomposition to a relation, then it may lead to problems like loss of information, damage of data, and many more things. So that we have to keep in mind while applying the decomposition techniques. Also, the decomposition is used to eliminate some of the problems of bad database design like anomalies, inconsistencies, and redundancy. So this is one more important aspect of decomposition. While using the decomposition, it is used to eliminate some of the problems of bad design, bad database design. Like, so what are that bad database design problems? Like anomalies, we can say disadvantages of databases, inconsistencies, that means database is supposed to be not in a consistent state, and redundancy. We know what is redundancy. The redundancy means where the same information may be duplicated more than one time, or we can say duplication of data. So to eliminate such kind of things, we have to apply proper decomposition technique to a relation. So this is what a simple definition of decomposition in a decomposition of relation in a table for a database. Now we would like to see there are some of the properties that are exist for a decomposition techniques. So there are two techniques actually. One is a lossless decomposition, which we have to understand the dependency preservation. These are the two properties that we have to understand while using the decomposition. While use the decomposition to eliminate the loss of information. So what is the first property? The first property is lossless decomposition ensures. Now when I am saying that this is lossless decomposition is one of the property of decomposition, then we have to understand that why lossless decomposition is more important property in a decomposition. So the lossless decomposition ensures, what it will ensure? It ensures no information is lost. Let me repeat, no information is lost from the original relation during the decomposition. So this is the very important line, very important property of lossless decomposition is what? Whenever we are applying the lossless property of a decomposition, there should not be information lost from the original relation during the decomposition. So this is the first thing. When the sub-relations are joined back, the same relation is obtained that was the decomposed. So this is one more important thing. While we are decompose our table into more than one table, and after decompose we have to join that table. So after joining, that particular original relation should be maintained. So this is what the next next point. Every decomposition must always be lossless. So whenever we are applying a decomposition in any of the relation, the data should be lossless. That means there is no information should be lost or damaged while applying the decomposition. So this is what an property of lossless decomposition. Then we have to keep in our mind another property, that is dependency preservation. So what it will ensure? Dependency preservation ensures none of the functional dependency that holds original relations are lost. That means whenever we are applying decomposition techniques, we know that according to the normalization, there should be some functional dependency between the relation. So that should hold the original relations. Original relations are lost. The sub-relations still hold and satisfy the functional dependency of original relation. The next important point of dependency preservation is whenever we are applying the property of decomposition like dependency preservation, when we are decompose our table into decompose our relation into a sub-relation, that still hold and satisfy the functional dependency that exists in original relation also or original table also. So these two properties of a decomposition, that is dependency preservation and lossless decomposition, that ensures this many properties while applying the decomposition on a relation or a table. So this is what an property of decomposition. Now according to the decomposition, there are two types of decomposition. So the decomposition of a relation can be completed in the following two ways, or we can say it can be categorized into two ways or two types of decomposition. The first one is the lossless decomposition, lossless joint decomposition, or a lossy joint decomposition. We can say lossless decomposition also, we can say lossy decomposition also. But in the examination, they may ask about the lossless joint decomposition and lossy joint decomposition. So the meaning of both the terms are same. So that is what the types of decomposition. Let us understand this each type with an example. Now let us understand what is lossless decomposition. Now consider a relation R, or we know what the relation is. A relation we can say, or we can say table. Consider a relation. Consider there is a relation R which is decomposed into a sub relations, that is R1, R2, and Rn. So when we have a relation R, let us decompose that relation into more than one relation or more than one table. So that can be decomposed into R. R is decomposed into R1, R2, and R3, and so on. So this decomposition is called lossless joint decomposition. When the join of the sub relation results the same relations R that was decomposed. Now what is the meaning of that particular line? So the lossless decomposition says that when you applying the lossless decomposition, for example, if I am saying that there is a relation R and we are going to decompose that relation R into more than one table, that here you can see R1 to Rn. Now after doing the decomposition, we will receive some of the sub relations. So based on the sub relation, after that when we are joining that relation once again, and that same relation, that means the original relations is supposed to be exist, and that is what the decompose, that should be maintained. So that is what the meaning of lossless joint decomposition. For a lossless joint decomposition, we always have R1, that means we always have the sub relations like R1 join R2, R3, and so on, and it is equals to the original relation, that is R. Here you can see this example. So whatever we have understand in this particular area, this particular portion, that is supposed to be written in relational algebraic procedural query language form. So whatever the joining after sub relation, when we are joining this operation, so this is the join operation that I have written. So this is equals to the original relation. What is our original relation? Our original relation is R. So here where this is the join, natural join operator. This operator is a natural join operator that we are going to use for a joining purpose, for a decomposition technique. So this is what lossless join decomposition. Now let us understand the lossless join decomposition with an example. Now consider the following relation R that has 3 attributes or a 3 column, that is ABC. Here you can see there are 3 columns ABC. There are some records that we have inserted here, and that can be represented with this one. It can be represented. The table is, that means the table can be represented, a table or a relation can be represented in this way. This representation of table is called schema representation, and this representation is called the table representation. Here also it is a table schema representation. So this is what in our example. Now we are going to apply the lossless decomposition, lossless joint decomposition in this table. Let us see how it will be executed. Now you see in this example, lossless joint decomposition example, consider this relation, that means our example is decomposed into 2 sub-relations. That means if you can see in this table, there are 3 columns, 3 attributes A, B, C. Now what we are going to do, we are going to decompose into 2 sub-relations. And what are that sub-relations? That sub-relations are R1, and R1 is now R1, that means that is a one sub-relation 1, and that is that contains 2 attributes or 2 columns, that is A and B, and another our sub-relation, that is R2, and that contains 2 attributes or 2 columns, that is BC. So now according to this this relation we can decompose, you can see here also, you can decompose our relation into 2 sub-relations R1 AB. That means R1 contains 2 columns, now R2 contains 2 columns, but make sure that that particular attribute name is supposed to be exist. Now here you can see in this example also, when we are decompose our relation, into a sub-relations, that sub-relations must contain the common attributes in it. That means here you can see R1 contains AB and R2 contains BC. That means here you can see this B column, that B attributes is common in between them. Why? Because why we are keeping that common? Because according to the properties of join, any one of the attribute of the relation, any one of the attribute of the table column should be, the name of that column should be same. So this is what we have to keep in mind while we have to do the joining also. Let us see how that particular thing is executed. Now what we have to do after decomposition of these 2 table, we have to draw the table for that. Let's see how it will be executed. Now you see the 2 sub-relations are look like this way. R1 AB, we have to draw the table for AB from the original relation. Similarly, we have to draw the table for R2 relation BC. Now let us check whether this decomposition is lossless or not. What we have to see after this is our sub tables from that we have derived from our original table R1 and R2. That means what I am saying here, R1 and R2 is derived from for R. That means R is our original relation. Now we will have to see after joining this both the table, whether after joining or after decomposition of table, we would like to see whether that particular decomposition is lossless or not. For the lossless decomposition, what it should be, what is the main condition for the lossless decomposition? The main condition is R1 join R2, whatever the sub relations we have, after joining that relation we should receive the original relation. Now you can join, after joining these 2 table we will definitely receive our original table. That means it will satisfy the properties of lossless joint decomposition. So this is what a simple example of lossless decomposition. Now let us understand, now if we perform the natural join, of a sub relation of R1 and R2, that means whatever the relations that we are created from the base relation, so these relations we have created, these relations we get, these sub relations we get from the R, from R, that is our original relations. Now after performing the natural join on R1 and R2, we will get this table. And you can see that this is our original table also. So the relation is the same as the original relation R. That means the table is the same as the original table R, that we can also say. Thus we conclude that above decomposition is lossless joint decomposition. So this is how this lossless decomposition joint will work while applying on a different relation or a different table. That's a very simple technique. It's easy to understand also. Now let us talk about some of the important points, some of the important notes, or we can say important points about lossless joint decomposition. What is that important point? The lossless joint decomposition is also known as non-additive joint decomposition. What is that? Let me explain once again. The lossless joint decomposition is also known as non-additive joint decomposition. You can also call that lossless joint decomposition is a non-loss joint decomposition, that I have not written here in this presentation, in this video lecture, but you can also call this lossless joint is a non-loss joint decomposition, and one more name is non-additive joint decomposition. This is because the resultant relations after joining the sub-relations is the same as the decomposed relation. Why we can say that this is non-additive or non-loss? Because after decomposition of our original table R into R1, R2, and after and then we are going to perform a natural join on the sub relation on R1 and R2, we supposed to receive the original relation. This is why we can say it is a non-additive joint decomposition or a non-loss joint decomposition. Another important parameter that we have to understand in lossless joint, that is no irrelevant tuples appear after joining the sub relations. That means after applying the join on a sub relations, we are not supposed to get any of the irrelevant tuples in our output table. So this is what and important points that we have to keep in mind while understanding the lossless joint decomposition. Now another technique that is for the decomposition, that is lossy joint decomposition. Let us understand that. Consider there is a relation R and which is decomposed into a sub relation R1 till ... Rn. Now decomposition is called a lossy joint decomposition when the join of the relation does not result the same result that was decomposed. Now it is something like opposite to the lossless joint decomposition. What we understand in lossless joint decomposition, so after decomposition of a relation and when we are joining both the table, we will receive the same table in lossless. But when we are talking about this lossy joint decomposition, in that case the relation does not result the same relation. That means we are not supposed to receive the same relation as we have in a original table. So that is what the lossy, or we can say the lossy joint decomposition in a DBMS. Now the natural join of the sub relations is always found. What is that? The natural join of the sub relations is always found to have some extraneous tuples. That means in the case of lossless join, we will receive some of the we does not have any irrelevant tuples in a lossless joint decomposition. While in case of lossy joint decomposition, we may found, because we are applying the natural join, so in case of we may found some of the irrelevant tuples, that is extraneous tuple in a table. So this is an important point. For a lossy joint decomposition, we always have R1 natural join R2, natural join R3, and so on, and the subset of R. That means it always satisfy which property? That means when we are applying a lossy joint decomposition, we are not supposed to have same table as in the original table. So when we are not receive such kind of required table as original table, and that kind of decomposition technique is called a lossy joint decomposition, and this is a natural join operator for a joining purpose of two table. So this is what and simple understanding of lossy joint decomposition. Let us understand. Let us understand the example of it. This is the R. This is the relation in that we have taken three attributes, three columns A, B, C. Once again, let me explain what is that. This is the table, or we can say relation. The data can be represented in two ways. One, you can represent it with a table, and one you can represent it this within a schema. So this representation of table is called a schema, and this is table representation. Let us see how lossy joint decomposition will work. Now once again, consider this relation, and we have to decompose this relation into sub-relations. So we are decomposing that relation into a two sub-relations, that is R1 AC, R1 A comma C. In R1 we are taking two columns, that is AC, and R2 sub-relations we are taking two columns, that is B and C. Now you can see in this this decomposition technique, the C is common attribute. The C is common attributes or common column. So this we have to keep. Why? Because while for a joining purpose, any one of the attribute, any one of the column names should be same. So that we have to keep in our mind. Now you see the two sub-relations. This is our original table. This is our original table, and that particular table. This is our original table. Now that original table, from the original table, we are going to decompose our table. We have decomposed our table. The first table is R1 SE. R1, that is our first sub-relation, and R2 is our next second sub-relations. The R1 contains AC column and R2 contains BC column. So according to the representation of these both the sub-relations, we can represent this table in this way. From this table, we can represent this table in this way. So this is what the decomposition of relation. Let's see further. Now let us check whether the decomposition is lossy or not. Let us check whether the decomposition is lossy. Now for the lossy decomposition, we must have R1 natural join R2 subset R. That means after joining the two sub-relations, we are not supposed to receive original relations. That we can call it as a lossy joint decomposition. Now if we perform the natural join on the sub-relations of R1 and R2, that means if I am applying the natural join R1 natural join R2, if I am applying natural join to this both the tables, what we will receive? We will receive this table. We will have this table. That means you can see that here there are more number of records, or we can say there are some extraneous records, or we can say there are some irrelevant records are there. So this is not our original table. Now what is our original table? This is our original table. Here it will contain only 3 records, and this is look like this way, but this is not our original table. So the condition is, does not satisfy. So we can say that this particular table is a lossy joint decomposition. This particular table is called lossy joint decomposition. Why? Because the after a decomposition of a relation, we are not received the same table, or we are not received the original table that we have in the form of example. So we can say that, and also it does not satisfy, it is satisfied the property of lossy joint decomposition, that is R1 natural join R2 subset R. So this is what an example of lossy joint decomposition. Now let us understand some of the important parameters of a lossy joint decomposition. This relation is not same as the original relation R, and that contains some additive or extraneous tuple clearly shows that R1 natural join R2 subset R. Thus we conclude that the above decomposition is a lossy joint decomposition. So that means we can say that now this decomposition is a lossy joint decomposition, because the original table and original table and output table is not same. Then some of the notes, let us understand. The lossy joint decomposition is also known as a careless decomposition. The lossy joint decomposition is also known as careless decomposition. This is because the irrelevant tuples get introduced in a natural join of the sub-relations. The additive tuples or extraneous tuples makes the identification of the original tuples difficult. So when we have some additive or extra tuples, the identification of the original tuples, or we can say the importance of the records, are very much difficult to find in a lossy joint decomposition. So these are the important points that we have to understand and keep in our mind while understand the lossy joint decomposition. So this is what the two techniques in a DBMS, two decomposition techniques in a DBMS. The one we understand, that is lossless decomposition. Another one that we understand, the lossy joint decomposition. We have also seen the examples, we have also seen the property of it and some of the important parameter of this both the techniques. Now let us differentiate these two lossy compression techniques, or lossy joint decomposition or lossy compression. We can say lossy joint or lossy compression also. So let us see that lossy compression versus lossless compression. In a lossy compression is the method which eliminates the data which is not noticeable, while lossless, remember here we are keeping first lossy, not lossless. So what is lossless and what is lossy? Let us differentiate. In lossy comparison is the method in which we are eliminate the data which is not noticeable, while lossless compression does not eliminate the data which is not noticeable. In lossy compression, a file does not restore or rebuild in the original form, so that we know already. While in case of lossless compression, the file can be restored in the original form. The lossy compression, the data quality is compromised because we are not getting the same result as we have an original. But in case of lossless compression, does not compromise the quality of data. The lossy compressions reduce the size of data, while in case of lossless compression, it does not reduce the size of data. So these are the four differences between lossy compression and lossless compression. Let us see many other differences also. The algorithm used in lossy compressions are transform coding, discrete cosine transform, discrete wavelet transform, fractional compression, etc. In case of lossless joint, they are using such kind of algorithms like run length encoding, Lempel-Ziv-Valk, Hoffman coding, arithmetic coding, etc. In a lossy compression, it is used in image, audio and video, while a lossless compression used in text, image and sound. Lossy compression has more data holding capacity, while in case of lossless compression has less data holding capacity than lossy compression technique. Lossy compression is also termed as irreversible compression, while a lossless compression is also termed as a reversible compression. So these are the simple comparison between lossy compression and lossless compression for a decomposition of a relation in a DBMS. Now let us see the summary of in this video lecture what we have covered. We have seen the definition, we have seen the decomposition, what is decomposition, the definition of decomposition. We have seen the two techniques of decomposition techniques. One is a lossless joint decomposition, another one is a lossy joint decomposition. We have also understand that both the techniques with an example, and we have seen the property of each decomposition technique. We have also seen and proved that with an example that how it could be treated as a lossless and how it could be treated as a lossy joint decomposition. We have also differentiate the lossy compression and lossless compression for a particular relation, how it will be related to in a DBMS. So this is what in this video lecture. Thank you all.